guys, Mrs. Traver here. Today we're going to talk about the Pythagorean Theorem. It's a big topic in geometry, so I'm excited to get started. Your learning target for today is you'll be able to use different tools to find the Pythagorean Theorem, and you know that when you have a right triangle, you're successful when you know that the two smaller sides squared and summed equal the square of the larger side. Let's jump in. It's kind of cool how we're going to come upon this. So before we get started, I want to mention some vocabulary. You might have seen this in your textbook earlier, but if we have a right triangle, there's a right angle marked with that box, and across from the right angle, diagonal to it, is the longest side. This is called the hypotenuse, and it is always the longest side. We call this side C, so that we can make sure we know where our letters are. The other two sides are called legs, here and here, and we use A and B for those. So they can be interchanged. It doesn't really matter which one's A and which one's B, but the legs are A and B, and the longest side, the hypotenuse, is side C. So here's what I want to do is I have a picture of a square drawn twice here, and we're going to find the area of the large square. I mean like the whole thing, ignoring that white cutout. And let's notice that it's made up of right triangles. So there's 4 right triangles. They're similar and congruent on the outsides, and let's label them the way we know how. I'm going to do the little leg A and the big leg A or B for each one. So I'm labeling all of these guys. And then all of their hypotenuses are in the inside C, or hypoteni. All right, so it says find the area using A plus B as a side. So what it's saying is notice that this square has this side from here to here, and it is the length A plus B. And the same thing here, it's got another side that is A plus B. So if we were going to find the area of the square, it would be quantity A plus B times quantity A plus B. Well, you guys are pretty good at multiplying binomials. You could work this out with the box or a FOIL method and get A squared plus 2AB plus B squared. There's some work in between here I skipped, but you've done a bunch of these practice problems, so check my math and make sure I looked good. Now, I want to find the area of this square the same way, but different kind of. It says find the area by adding together the smaller pieces. So I've got 5 pieces here. I've got 4 of these triangles, and I've got 1 of the square. So let's see, the triangles are found by saying 1/2 base height, and for each one of the triangles, our base was A and our height was B. So 1/2 A times B. Plus, we're going to add to that one of these squares, and it was C by C, so C times C. So let's see, we've got 4 times 1/2 times A times B. I'm going to kind of add these up here. So 4 times 1/2 is 2, so 2AB plus 1 times C, so that's C squared. 2AB plus C squared, and this is our area. So notice we found the area 2 different times, and we've got 2 different functions for it. So let's see if we can put this all together. For my first one, I said area was A squared plus 2. Whoa, that looked a little funny. Let me fix that. For my first one, we said area was A squared plus 2AB plus B squared. And for my second one, we said area was 2AB plus C squared. Now, these are the same square, so they must be equal. So let's set them equal to each other and see what we can do. I've got A squared plus 2AB plus B squared on the left and 2AB plus C squared on the right. Notice this term is in both of them. So what I could do, really, is just get rid of it on both sides. So I'm going to really subtract it from both sides, and it'll go away. So if I subtract 2AB from both sides, that's gone. On the left, I'm left with A squared plus B squared. On the right, I'm left with C squared. Now this is the Pythagorean Theorem. Ta-da, you came about it. That was actually what we just did, called a proof by construction. So I constructed something to prove to you that for every right triangle, if we have A, B as legs and C as the hypotenuse, that there's this relationship that A squared plus B squared equals C squared. Now, we can use that, and you might be asking, does this always work? So I want to show you this Desmos tool to prove it to you. This is in your textbook as well, but here's what we've got is it's giving you a triangle here, and it says, what if the sum of the angles of the triangle, use it to investigate? So that's not the right tool. All right, you might be asking yourself, does this always work? Does a squared plus b squared always equal c squared? So let's check this out with this Desmos activity. If you click this in the slideshow, it'll pop up for you as well. So here is this picture, and notice how it's looking. I've got these triangles where they've got this length called a, and then this square that's got length b. And notice I can make a bigger or smaller, and b bigger or smaller. And what it's trying to get you to recognize is that this square has side A by A. So if I was going to find the area of this square, it's A for the length and A for the height, so it's A squared. And then if I was going to find the area of this square, it was B by B, so it's B squared. Now over here, I've got a right triangle made from A and B that's length C. And I can change how big this is so it'll convince you of what's going on. Here's what's cool. If a squared plus b squared, let me get that to go away. If a squared plus b squared equals c squared, I could do it for any setup. So let me see if this will work out. If I try to move these pieces in, will it work? Let me get myself set up. I think I gotta put this back in here first. There we go. Okay, let's see. So if I set my square in first, it's hard to get it to set where I want it. And then I set these pieces in. Let's see if I can get it into just the right place for it to work. Okay, I've got my triangles in place. I just got to get my square in the right place. It looks like it's a little bit off. Let me see if I can... Whoa, that was too much. There's some pieces missing. How did I get it back in that place? What the hell? All right, let's see if we can get this to work. So if we click it, it'll open up for us a Desmos activity. And let's check that out together. So let's see, we've got a square down here that is a by a, therefore a squared, and you've got a square here that is b by b, therefore b squared. On the outside, these two are a squared plus b squared. Over here, you've got a right triangle made by c, so this box would be c squared. Now, if I could fit these pieces, which they move, into this box perfectly, then it would prove that the area of these two equal the other. Let's try it. So I can set my box in, and I can move around my triangles into just the right places to make it equal itself. Now what's cool is this will let you move around the sizes. So maybe you're saying, okay, you just made it work perfectly. Let me set everything back where it belongs, and then I'll show it to you with a different setup. So the Desmos has these slider tools on the left that you can play with. And say I want to make the B box smaller. Notice everything shifts proportionally. And I want to make the A box smaller maybe. So I changed it a little bit. Now it's A side 5, B side 8. Let's see if it still works. So if I put in, let me make it, there we go. So it's easier to see. Now you can play with this again and see how it works, but every time it'll work. Notice down here, these aren't even triangles anymore, but it'll still play out for you. You just got to move them into just the right places. So I encourage you to try this out and see how it goes. But moving back to our slideshow, let's do some practice of these guys. Here are some problems. We're going to put a squared plus b squared equals c squared into action. So as a reminder, I'm going to put it up here. And let's first label our sides. So C is the longest side across from the right angle, and A and B are the other sides. It doesn't matter which one's which. Let's set it up. 10.2 squared plus 6.1 squared equals x squared. Now this piece can go right in our calculator. Matter of fact, that's what I encourage you to do. So let me open up my calculator. I've got 10.2 squared, 104.04. I'm going to jot that down because mine isn't as fancy as yours. I can't show you my other one. And then I've got 6.1 squared is 37.21. And let me add those up. That plus 104.04 is 141.25. And now these equal x squared. So I want x, that's my goal. And right now it's being squared, so I need to take the square root of it at the end. So here's my answer, and if I use this button, it'll take the square root of it. So it's approximately 11.88. So x is approximately, whoops. X is approximately, I'm going to use the approximately equals to, I forgot it was 11.88, I think. Let me double check. Yeah. And we're talking yards. Let's try another. So we've got C as our hypotenuse and A and B for the other two sides. So I've got 4.5 squared plus 9.4 squared equals x squared. And now again, you can type these each in your calculator. You probably have one of these calculators, or maybe you have one of these. Doesn't really matter, but you can actually type it all in at once. So I'm going to do that. 4.5 squared plus 9.4 squared like this. So hopefully that makes sense to you, but you can type it in like that. So I got 108.61. If you're on your other one, it's going to look pretty much the same. 4.5 squared plus 9.4 squared. So again, the same. And then from there, you can take the square root of that. So this is equal to x squared. We're going to square root both sides. So I've got the square root of 108.61. And I've got 10.42 approximately, so x is approximately 10.42. And we're talking feet on this one. It'll pretty much always be something you have to round. And as a quick mention on rounding, my calculator actually gave me 10.421612 and so on. Cut it off at the hundredths place, and if your neighbor was greater than 5, then move that number up. If it is lower than 5, 4, 3, 2, 1, or 0, keep it at that number. Moving forward, two more, and there's something different going on in this slide I want to show you. So I've got my hypotenuses across from the right angle C. My other two are A and B, and let's add it up. A is 8.9, so 8.9 squared plus B, this time is x, plus x squared, equals 13.8 squared. So notice on my last slides, the thing we were looking for was the hypotenuse. And on this slide, the thing we are looking for is going to be a leg each time. So it's a little bit different setup. And you can see it here because the x squared isn't on the equal side, it's on the equation side. Let's simplify all the same. 8.9 squared. 8.9 squared is 79.21. And 13.8 squared is 190.44. All right, just like any regular equation, we're going to solve for x by subtracting this from both sides. So I'm going to take away 79.21 from each side. So minus 79.21 is 111.23. And lastly, take the square root. So there's just one extra step there that we're looking for, 111.23. So approximately 10.55. Now my calculator told me 10.5465, but notice my neighbor was a 6, so I moved this up to 0.55. We're talking about miles in this one. Let's do one more of that type. So I've got my hypotenuse across from the right angle C. My other two are A and B. So I've got 11.1 squared plus x squared equals 13.9 squared. Now let's write our work a little bit differently this time. Instead of calculating right now, I'm actually just going to subtract 11.1 squared from both sides. So I'm left with x squared equals whatever this is. Now this you can type in your calculator. I'm going to show you that. Okay, so I did, and I got 67.77. So I've got x squared, I've got x squared equals 67.77. And then lastly, let's take the square root of both sides. So x is approximately, let me take the square root, 67.77, 8.23. And we're talking about meters. Now, I just want to show you one more thing, and this is just for fun. One of my favorite movies growing up was The Wizard of Oz, and I wanted to show you a clip from that movie where Scarecrow actually makes a mistake. He just got his brain now, and I want to show you what's going on here. See if you can catch the mistake. I'm going to show it once, but it's on my slideshow if you want to go see it again and see if you can catch it. Here it comes.
Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
Ph.D.?
That's Doctor of Thinkology.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! Rapture! I've got a brain! How can I ever thank you enough?
Well, you can.
Alright, see if you can catch the mistakes. There are several. Tomorrow, if you want, you can join and I will point them all out to you if you can't find them. I'll see you later, guys. Bye.